So we're studying astronomy right now, and we've done things like the planets in the solar system. And I just want to spend a little bit of time going beyond the solar system, talking about the universe. Now, technically, the study of the universe is called cosmology, the study of the cosmos. Okay, and so to get into that, the thing is, uh, the only thing we get from Earth, or get on Earth from the rest of the universe, is light. Okay. Now, yeah, you get an occasional meteor and stuff, but those are just from the little local area in our solar system. If you want to study what's going on outside the solar system, like other stars and other galaxies and the universe itself, it's expanding, and that some of the big questions that astronomy deals with, and some of the amazing answers, you have to understand how light works. Since what we get from the cosmos outside is light, like from the stars and the galaxies, looking through telescopes, analyzing it, in different, wavelengths and things like that. You have to understand the nature of light. And so what we're going to do here in this lesson is talk about light and what is light, the colors of the spectrum first, and then the fact that light is electromagnetic radiation, and there's some wavelengths that are light, but we can't see them because our eyes don't have the sensors for that. So that's the two main things we're going to deal with. Let's get into the lesson here. And so white light and the spectrum is the first part, okay? Studying light, that comes from the sun. I'll just tell you right now, it has all the different colors of the rainbow in it. The white light does. But the history of science, I also think it's important that we understand that science is made of a series of discoveries that are built on each other from different scientists. So I want to do some of the historical perspective from this too. And now, who was that scientist guy we studied earlier? He invented the laws of gravity and the laws of motion. For every action, there's an equal and opposite reaction. And what else? An object in motion stays in motion unless acted upon by a force. And there's another one which we haven't gotten to yet. I hope we can this year. Force equals mass times acceleration. Okay, so who was that scientist? Do you remember the name of the guy? The Apple thing story. It didn't happen that way, but it's Isaac Newton. Okay, so Isaac Newton is the let me get to the next slide. There we go. So the study of light is known as optics. Now remember, if it's white, you got it right. But if it's yellow, just, I want you to be exposed to it. Just pay attention, okay? It's called optics. Okay, you might know that an optometrist or an optician, an ophthalmologist, those words, if you've ever heard of it. Optometrist makes glasses, and then an ophthalmologist is the guy who studies eyes and eye doctor. So anyway, the study of light is known as optics, and it gets its name from a title of a book by Isaac Newton. Our good friend Isaac Newton. This is the actual photograph of the cover of the book that he did. Now, he spoke English. He was an Englishman, right? Optics, or a treatise of the reflections, refractions, inflections, and colors of light. Okay, so this is Isaac Newton. So we're back in the 1600s here when he discovered let's just write this down. In the 1660s, Newton used a prism to discover that white light is composed of all the different colors of the spectrum. Write that down. Isaac Newton discovered that all the different colors in the spectrum are in the white light. And I kind of want to go over a little bit to describe the experiment he used. So I'll tell you what, if you need time to write that down, pause it, write it down. Okay? It's a crucial learning you got here. White light is composed of the different colors of the spectrum. Okay, if you need more time, pause it and go on with it. Now, this picture right here is, to my mind, really cool. This is in Isaac Newton's own drawing that he made of his setup, of his lab he did. Now, what he had here was the window facing the south, so the sun would shine in the window, and he put a thick velvet curtain so none of the light would get through, but he had a hole in it, right? He put a hole in it so the light would come shining in, the beam would come shining in the window, and then he kind of used a lens to sort of focus it a little bit, and then he has, what's this thing look like? The triangle? What's that? A prism, right? And you've seen prisms before. If we were in the classroom, I'd show you a prism, and actually I'd try to, do parts of this experiment anyway. And what it does is it breaks the light into its different colors. And so what he has shown here is he has a screen that will try to isolate an individual color from the spectrum that it breaks into from the prism? And then can you put it in a different prism and break it up anymore? And he realized, no, you can't. Once it's purple, it's purple. Once it's red, it's red. So white light, you can break into the various colors, red, orange, blue, indigo, violet, red, orange, yellow, blue, green, indigo, violet. But once it's in one of those colors, you can't break it up anymore. Okay, and so that's what this is showing, that here you get the color and with another prism, and boom, purple stays purple, orange stays orange, red stays red. Now this is kind of a remarkable thing, and that's his handwriting right there. Okay, so let's kind of go ahead and get into observation here. Now, if we were in the classroom, I'd be showing you a prism with the light broken up, but we aren't in the classroom. So here's, I want you to look at this picture and record the colors of the spectrum produced by the prism. Now it even says it right here. Okay, let me see if I can get out of your way. Okay. Red, orange, yellow, green, blue, indigo, and violet. Okay? So, that being said, write those down. Red, orange, yellow, green, blue, indigo, violet. Again, if you need, time in the way, if you need to pause it to write that down, do so, okay? Because I want to kind of move on here to the next little bit.